Hi students, in this video I'll be going through the 2014 O-Level Additional Mathematics Paper 1 question 10. Right, so let's read the question. So a gardener uses 130 meters of fencing to enclose a plot of shape shown above. Okay, but I put the shape below. Okay, the shape consists of two equilateral triangles of side x meters and a rectangle with sides x meters and L meters. Okay, show that the area of the plot is 130x minus 4 minus root 3 times x squared over 2. Right, so over here we have two equilateral triangles, so maybe we can label the length first. Okay, so this would be x meters over here. And of course, all three sides are the same length, so that's why the length of the rectangle is also x meters. Okay, so since they want us to show that the area of the plot is given by this expression, right? So we need to start to work out the area of the plot. So if you think about the area of the plot, it will be just this triangle, okay, plus this rectangle, plus this other triangle over here. Okay, so both these equilateral triangles actually have the same area. Okay, so if you recall, we can actually work out the area of a triangle if we know the length of two sides and the included angle. So in this case, we know the length of the two sides is x, and then the included angle is 60. So we can actually use the formula area of triangle equals to half AB sine C. Okay, so let's go ahead and do that. So area of triangle. Okay, so I'm going to write out the formula. So it's half AB sine C. Okay, for area triangle that is triangle ABC. Okay, so now the A and B will both be x, right? And the included angle will be 60. So in this case, we have half x times x sine 60 degrees. Okay, so 60 degrees is a special angle. Okay, so it gives us a ratio of square root 3 over 2. Okay, so half x squared times square root 3 over 2. Okay, so that will give us square root 3 over 4x squared. Okay, so this will be the area of one of the triangle. Okay, so now we can find the area of the plot. So the area of the plot will be 2 times of this. Okay, that is because there are two triangles plus the area of the rectangle. So it just be 2 times square root 3 over 4x squared plus x times L, right? For the area of the rectangle. Okay, so you'll get square root 3 over 2x squared plus xl. Okay, so let's call this equation 1. Okay, but if you look at the expression that they want us to find, it doesn't consist of any L, right? So this means that we need to come up with another equation in order to substitute the L away. Okay, so you need to scan the question and look for info. Okay, so there's one piece of info that we have not used, which is the total length of the fencing is 130 meters. Okay, so the fencing will be over here. Okay, this one, this one, this one, this one, this side plus this side. So in other words, we add up all these 6 sides, right? We're going to end up with 130 meters. Okay, and this is where the second equation is going to come from. Okay, so over here we have 4x plus 2L. So this is also L, right? Will be equals to 130. Okay, so 2 times L plus 4x equals to 130. Okay, so we're going to divide by 2 to everything. Okay, then we're going to bring over, all right? So L is going to be 65 minus 2x. And this is going to be my equation 2. Okay, so now I'm going to sub equation 2 into 1. Right, so that's going to give us A equals to square root 3 over 2x squared plus x times 65 minus 2x. Okay, so that's what we're going to get. Okay, so now if you look over here, they have combined everything as a single fraction. So we're going to combine also. Okay, so to combine everything into a single fraction, we need to make both the denominators 2. Okay, so if we make this denominator 2, then on top we need to compensate with another 2, right? Okay, so this is what we have. Okay, and once the denominator is both 2, then we can add up the fractions already. So we'll have square root 3x squared plus 2x, 65 minus 2x over 2. Okay, so it's very important that you keep an eye on what the final expression should look like. So there's 130x over here, right? So you can actually see that if we multiply this 2x to the 65, then you will be able to get the 130x, right? So this means that we will need to expand this brackets over here. So square root 3x squared plus 130x minus 4x squared over 2. Okay, so we're going to put the 130x in front because that's what they want. And then we'll group the x squared terms together. So negative 4x squared plus square root 3x squared over 2. And actually you can see that we are almost there already. Okay, the form that they want. All we need to do is factorize out negative 1 in front and x squared behind. Okay, so we'll do it step by step. So 130x. Okay, factorize out negative 1, we'll get 4x squared minus square root 3x squared. Okay. So if you expand this back, you should get back the previous step. So negative 1 times 4x squared, you get a negative 4x squared. Negative 1 times negative root 3x squared, you get your root 3x squared, positive root 3x squared. Okay, then let's factorize out the x squared from both of these and put it behind. So 4 minus root 3, and then put the x squared outside over 2. Okay, so we have shown it already. Okay, so this question is not too difficult. Okay, but I think the difficult part is to manipulate the expression and then put it in the form that they want. Okay, so this requires some practice. Okay, so even after trying it for one time, okay, you can redo the question and then get more familiar with this. All right. Okay, let's look at part B of the question. Okay, so they say that given that x can vary. Okay, so I'll do part B below over here. Given that x can vary, find the value of x for which the area of the plot is stationary. Okay, so now they say that the area of the plot is stationary. So we know that at stationary value of a, what we're going to have is that dA dx is going to be equals to 0, right? Okay, so let's write out the a again. Okay, so this is part B. So a is equals to, if you recall, just now we managed to obtain this, right? Square root 3 x squared over 2. Okay, so instead of differentiating directly this expression, I think it's easier if we break up the fraction into like this. Okay, split it up into 2 and then we differentiate each one separately. Okay, so minus 4 minus root 3 over 2 x squared. Okay, so this is what we have. Okay, so I think after you break it up this way, it will be easier to differentiate. Okay, so 130 over 2 is 65x. Then we have minus 4 minus root 3 over 2x squared. Okay, so once we have this, then I think it's time to differentiate. So dA over dx. Okay, so differentiate 65, we just get 65. Okay, differentiate the second term over here. 2 comes in front. So 2 times the 2 below. Okay, maybe I'll just write the extra step. Okay, so the 2 goes in front, then multiply by this, and then you reduce the power by 1. Okay, so the 2 and 2 will actually cancel, so you get 65 minus 4 minus root 3x. Okay, so this is your dA dx. Okay, then let's continue. Okay, so at the stationary value of a, at stationary a, dA over dx is equals to 0. Okay, so we will have 65 minus 4 minus root 3x equals to 0. Okay, so we'll bring this one over. So 65 will be equals to 4 minus root 3x. Okay, we'll divide this down. Write x on the left side. So 65 over 4 minus root 3. Okay, so that will give me, if you calculate out and round off to 3 6 feet, you'll get 28.7 meters. Okay, so this means that at the stationary value of a, it could be a maximum or minimum. Okay, the length x over here Okay, you have to use 28.7 meters for the x, right? Okay, the next part of the question. Okay, explain why this value of x gives the gardener the largest possible area. So now they want us to find out whether for this value of x, right, is a maximum or minimum value. Okay, so to do that, we can use two methods. Either we use the first derivative test or the second derivative test. But in this case, if you look at the dy dx, okay, you look at the dA dx, sorry, it's actually very easy to differentiate one more time to get d2a dx squared. Okay, so that's basically what we're going to do. Okay, so let's do it. Okay, so let's write down the dA dx over here. Okay, so the dA dx that we obtained from part B was actually 65 minus 4 minus root 3x, right? So if we differentiate it one more time, okay, differentiating 65 is just constant, it becomes 0. Differentiating negative bracket 4 minus root 3 bracket x, right, will just leave us with the constant term in front. Okay, and if you calculate out this constant term, okay, it's negative 2.27. Okay, so d2a dx squared is a negative value. Okay, so if d2a dx squared is a negative value, then the stationary value of a will be a maximum point, right? So we'll write that since the d2a over dx squared is less than 0. Okay, so they want to explain why this value of x gives the garden the largest possible area, right? Okay, so let's answer it directly. X equals to 28.7 meters. Okay, the reason is because d2a dx squared is less than 0. We'll give the gardener the largest possible area of the plot. Right, so this is the working for this particular question. Okay, so I hope that you'll go and try, and then then you find out for yourself, okay, how such questions usually work.